Rice is one of the most important food sources in the world, but rice farmers face a serious problem: weeds. These weeds compete with rice for nutrients, leaving the plants weaker and harvests smaller. Removing weeds is difficult. Herbicides can harm the environment, and manual weeding is slow and exhausting. This is why we explored a scientific approach, using gamma radiation to make rice seedlings stronger and more resistant.
Gamma Rice, the future of rice cultivation from Kayuk National High School.
Rice is a staple food in Asia, but if rice weeds continue to reduce crop growth, food supply and farmer income would both suffer.
That's why finding a safe and effective way to strengthen rice plants is important. It's not just about farming, it's about food security.
Our goal was simple: seeing the exposing rice seeds to gamma radiation could make them grow stronger by improving their germination.
So if germination improves, the seedlings have a higher chance of becoming a healthy plant that can actually fight weeds.
We divided rice seeds into three groups. One treated with 250 grays gamma radiation, another with 300 grays, and one group with no radiation as control. We then measured their germination rate using a rapid germination assay.
The results were clear. The seed was exposed with 300 gray with the highest germination rate with 86.76%.
Seeds that are irradiated with 250 grays reach 66.67%, meanwhile seeds that are not irradiated reach 53.33%.
These numbers show that gamma radiation, especially at 300 grays, makes the rice seeds stronger from the very beginning.
Stronger seedlings means they can compete better with weeds for nutrients.
And if they compete better, farmers won't need as much herbicide and labor to control weeds.
That means healthier crops, less environmental damage, and more efficient farming.
For farmers, rice is more than just a crop. It's their livelihood, their tradition, and their hope for the future. But when weeds take over, that hope becomes uncertain. Stronger seedlings can change that story. With rice that grows faster and healthier, farmers won't need to spend as many hours under the sun pulling out the weeds. They won't have to buy as much herbicide that harms both their health and the environment. Instead, they can save money, save time, and use their energy to grow more food. And the impact reaches beyond the farm. Higher yields mean more rice in markets, more affordable prices for families, and more food security for communities that rely on rice every single day. This study may have started inside a lab, but its meaning reaches far beyond the walls of science. It points to a future where farmers can work with less burden, where families can eat with more confidence, and where communities have a steady supply of rice they can depend on. It shows how science is not only about experiments or discoveries. It is also about creating real solutions for everyday life, making farming easier, harvest stronger, and the future more secure for everyone.
We recommend future studies to test these seeds in soil, not just in germination strain.
And also to plant them alongside real weeds in order to test their resistance on real conditions.
In conclusion, rice seeds exposed to 300 rays of radiation improves their germination.
This suggests that induced mutagenesis is a promising way to develop weed-resistant rice.
It's not just a laboratory experiment, it's a step possible to better harvest and food security.
With further testing, this could help farmers grow stronger rice without the use of chemical pesticides or herbicides.